All right, hey guys. So today we are going to be going over network security solutions with TryHackMe. So here they have an intro, and it gives you some basic definitions of inline and how Snort can be used as IPS intrusion protection system. Then it gives you some diagrams here, and I'm just gonna briefly go over it and show you the answers as we go through this. So an IDS is a host IDS is going to be on the actual system, where a network IDS is going to um, be somewhere in line of maybe like a router or some type of could be like a Cisco firepower switch or something, or router or something of that sort. Um, but it's going to monitor the network traffic as it goes through it. Or it's going to have sensors throughout the network for that. So what does IPS stand for? Intrusion Prevention System. What do you call a system that can detect malicious activity but not stop it? Intrusion Detection System. Because intrusion detection systems can only detect but cannot actually prevent anything from happening. So those are the answers. I'm also going to put them in the description of this video so you guys can just copy and paste them if you guys want. But let's go ahead and go on to the next task. So until we reach task 4, we're not going to have to do much besides read through things and answer questions. So looking at their paragraph here, what kind of IDS engine has a database of all known malicious packet content? And that's going to be a signature-based IDS system. It's going to have signatures, hashes of known malicious packets or malware. What kind of IDS engine needs to learn what normal traffic looks like instead of malicious traffic? So that's anomaly based. You're going to have to establish some type of baseline on what your normal traffic is like. And based off of that, let's say it's 2 a.m. in the morning. Based off our normal traffic, we don't really have any traffic uh, egressing at that time. So egress is for like exiting. But if the anomaly-based detection determines that there's a spike, there's maybe like a terabyte of data egressing the network, then that would trigger an anomaly-based detection there. What kind of IDS engine needs to be updated constantly as new malicious packets are um, and activities are discovered? So that's going to be your signature base. Those hashes are going to have to be continuously updated um, in order for it to compare a executable or some type of uh, code against malicious code. All right, so that's task 2. Task 3, IDS IPS rule triggers. So here it gives you a file you can download. I remember when I downloaded this file, I actually had issues with being able to see inside of it. But just from looking at the contents of the file, in the attached file, the logs show that a specific address has been detected. Scanning our system of the IP address 10.10.12.168. What is the IP address? Running the port scan. So it's scanning this system. So this is the target. And so the attack box in this case is going to be 10.14.17.226. I could download the file. We can look at it real quick. So let me get that open. Oh, yeah, it looks like this one's going to have to, it looks like it's compressed. So you would have to uncompress it. Uh, let's see here. Let me get it on my Linux box. I'm pretty sure last time I did this, I actually had downloaded it, and so it should be here somewhere. Let me just pull it up. Folders here. I probably threw in the downloads. So let me go to downloads, and this file is going to be like 1010. Okay, let's see if I can find it real quick. I'm just going to scroll through this. Okay, I don't see it. Not a big deal. All right, so let me get it up and then we can take a look at the packet. Okay, so I'm just gonna make a notepad with these commands, but all I did was I decompressed the file, and after decompressing it, then you'll see a folder with the IP address there. But let me just go ahead and copy this over. So if you're looking to decompress it, you can do that. Okay. And so after decompressing it and running this command here, then I got the 10.10.112.168 folder here. And now when I open it, you can see there's some logs here. And from here, if you just open one of these, it gives you just your standard log of what you're seeing here. So you're seeing this IP address, which in this case, our victim, let's go ahead and go back to the try here. Our victim is 168. Okay. This 168. Yeah, this 168. You can see that this is the source and this is the destination, which is our victim. So we can say that that source is the attack box. And if you look through the logs, you can see how it trickles. It starts at one port and then continues onto other ports. And that's a telltale sign of someone scanning your ports, right? So we'll go ahead and just copy that and paste it into the answer right there. It's very easy. All right, let's go into task 4. So task 4 gets a little more interesting. At this point, you can start the attack machine. So I'll start that. I'll start the victim, yes. And then you could start your own attack machine if you choose to do so, or you can use theirs. So I like using my own. So let's go ahead and connect to the VPN, and then I should be good. And if you haven't done so already, I recommend watching my video on how I show you how to create a bash script so that you can connect to the TryHackMe's network. All right, so let me go ahead and run my script here. And once I run the script, I should be able to connect. Okay, and it's connected. So now what I'm going to do is I am just going to come over here, take a look at the IP address when it pops up, and we'll ping it and make sure that we're good. Although we should be. Go ahead and copy that, come over here, and we will run ping. All right, so we're getting our replies, so that's good. That means it's working. So let's go ahead and see what are we supposed to do here. So evasion via protocol manipulation. So here it tells you how you can evade maybe firewalls or any filtering by changing up your switches that you use for Nmap or Netcat when you're trying to enumerate. And then it provides you some information here on those different switches and what they do. A switch is just kind of like a dash and then usually a letter that signifies it's going to, in this case, dash L. It tells Netcat to listen for an incoming connection. So, usually if it's dash L, it's listening, dash B is verbose, it's going to give you a lot of information. Dash in this case is resolving host names, and dash P is going to be your port number that signifies a port number it's going to list it on. You don't have to memorize all these, although this is why you take notes. So if you ever forget this, you will know which ones to run. Maybe you make your own scripts or you just take notes in OneNote like I do. And usually I just, like, for instance, when I was trying to decompress the file, I was like, how do I do that again? And I just went back to my notes and I had a command there and I ran the command and I decompressed it. It's the same thing with these netcat and nmap commands here. You may never run them in the real world, but it's good to have in your toolkit. So, um, you could read through this if you choose to, but I'm going to go ahead and go on to the questions here. So use the following command, and we're going to use nmap to launch a UDP scan against our target. What is the option we need to add to set the source port to 161? I remember I had so many issues with this one because I thought it was dash P161, and it turns out it was dash G161. So yeah, don't do what I did. Save yourself the trouble and just run the command correctly. So I'm gonna go here. I'm just gonna paste that in, and we'll run it with that dash G161. I guess we'll see if that works. I think that was a capital G too. Was it a G? I want to say it was a G. It looked like a G. Go ahead and open this up. Yeah, that looks like a G to me. All right. You guys got to remember too, I did this a while back, so I'm actually going back for you guys. Um, thank you for subscribing. For those that have, for those that haven't, please support me by subscribing. It motivates me to create more content like this and to go back and to help those who are struggling as I was. Because that's what we're here for. That's what the cybersecurity community should be here for. Although you don't see that a lot of times. A lot of times you see them, telling you to go figure it out. Um, yeah, yeah, that's not gonna help anybody. So okay. Let's see here. G161. I think we should be able to run that. Let's run it. Oh, gotta do with root. Okay. So you gotta run sudo, I guess. Let me go ahead and pause it real quick. All right, so I just had to put sudo before my command, and usually the way it takes a while, but you now know the answer. It's going to be G161. All right. The target allows telnet traffic using NCAT. How do we set a listener on the telnet port? So that's easy. Netcat dash LBNP for the port is going to be 23. So you're telling port 23 to listen, being that it allows telnet connections. So that's pretty easy. We are scanning our target using nmap, and then we have this here. We want to fragment packets used in our nmap scan so the data size does not exceed how many bytes? 16 bytes. What is the option that we will need to add? So if you want to fragment, it's going to be dash FF, and that's going to fragment your packets if you want to get past some type of filter. Again, if you have issues finding any of these answers, like for instance, this is the answer here, dash FF, to limit the data in the IP packet to 16 bytes at the most. You could also control F it, and you can just look for like FF within this, just within this paragraph. So that helps us as well. Which of the above three arguments would return meaningful results when scanning this IP address? So the dash SF, in this case, will, because if you try the other type of scans, it doesn't provide you anything, last I remember. So let's go ahead and run that. So I'm just gonna put this in here. Right. Okay. So you have to run as root. Right, so I'm just gonna put my password in. Give me 1 second. Right, and I'm back. So yeah, it's running, and we can see from our previous scan that we had port 68, which is a UDP port, open. We can see here that we have scan still running. We'll see what meaningful results we get from that. What is the option for HPing3 to set the custom TCP window size? And that's going to be -W. And you don't even have to run these if you don't want to. But using that, we were able to see that port 22 for SSH and port 8080 are open on this victim. That's useful information. That means SSH is running as well as we have in this case some type of web server. Um, so that's helpful. That's good to know. Next, we'll move on to the next task, which is task 5. And very similar to when we were looking at that packet manually, they've got some tools that you can use to kind of like automate how you can look through packets and decode base 64 up here with Chef. You could also use Linux to decode base 64. Um, let's see here, encrypt the communication channel. Okay, and then here looks like you're using SSL, OpenSSL, and it looks like it's creating a cert. So we're establishing your encrypted, maybe a encrypted channel. Looks like it might be, or just an SSL cert here. Let's go here. Um, let's see what. Yeah, it's an encrypted communication channel. All right, and you're gonna set that up on the attack box and the victim box, if you choose to. So essentially, you're gonna set that channel, and then your listener, and then you're going to see the encrypted traffic and the fact that it's encrypted as you open up your Wireshark. So that's pretty cool. And you can see when you don't have that encrypted tunnel, um, that you're probably going to be able to see everything that's going through it, of course. So interesting. Using base 64 encoding, what is the transformation of the cat etc password? Okay, that's it there. Let me get a hint. Oh, okay. So I guess what they're asking you to do here is just take this here, just a command, and then just run it through base 64 encoding. If you want to be lazy about it, you can just honestly just go into base 64. They have decode and encode websites here. You can also run it on other things too here. So let's see here, base 64. Let me pull up the encoding site. All right, so here's base 64 encode. So I could just take this, throw it in there. That's the command. Click encode, and then it gives us this here, which I believe is what they're wanting. Y2, let me see. Yeah, that's exactly what they want. So you could just paste that in. Okay, the base 32 encoding. Da, 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 da. All right, so this is base 32 encoding here. And what is the original string? I want to say if you use base 32. Yeah, so in the same case, you just find like this one's base 64. You just find a site that will decode that into base 32, and then you'll see that netcat-l 8080. Okay, we'll move on to the next one. Using the provided open SSL command above, you create a certificate which will give you the extension .crt and the private key, which will give you the extension .key. What is the first line of the certificate? Okay, so let's go ahead and just look at, if you choose to do the above, that's great. I'm gonna just look over it real quick and see how quickly I can do this. All right. So let's just look at an open SSL certificate because this is a really easy one to answer. And honestly, you don't even need to do what they just showed you above to answer this one because anyone who's looked at an open SSL certificate, a .crt or a .key would know what the first lines are going to look like. I just Googled what an open SSL certificate looks like, and here you can see one. It's got begin certificate, end certificate, and that's it. That's when you generate it, when you run these commands above, let's just go here. When you run these commands, it will generate a certificate for you, and it will output something of this sort, which begins certificate and then your key and certificate. And that's pretty much it. It's not very difficult. I don't like to make things overly complex. So let's move on. So begin certificate and private key for where the private key, it's going to be n private key there. All right. Let's see here. What's next here? On the attached machine from the previous task, browse to port 8080, where you can write Linux commands. Note that no output will be returned. A command like this following will create a bind shell that you can connect to it from the attack box using this command here. However, some IPS filtering out the commands we are submitting on the form. Using one of the techniques mentioned in the task, try to adapt the command type in the form to run properly. Once you connect to the bind shell using netcat, find the username. Okay. Sure, we can run through this one. I remember I ran into some issues with this one. I remember it took me a while, and it was very painful. Like everything in Try Hack Me is very painful sometimes. Right, so we'll get logged in here. Come on, come on. God, that is slow. Is that what I'm supposed to connect to? On the tech bot. Tech machine. Cool. It says from the previous attack machine. Mine's 10.10.840. Is that what their IP address is? Yeah. Okay. Let me try that again. Let me try to access the site. All right, I'm gonna sit back because this is gonna take a while. Let me try pinging the IP address because it's taking longer than usual. Still getting that's working. Oh, gosh. Okay, guys, I made a huge mistake. I just realized I was using Google on my computer. I was like, why is this not working? All right, I have to use it on TagBox, of course. You know, it's kind of how it works. All right, so let me go away. All right, let me just go ahead and input that here. Okay. And we'll move this over here because that was a rookie move. It's a rookie move. Okay. So it's asking what's the commands, and then we go here. It gives us a hint. Using an extra space should be sufficient to evade the IPS in this case. Okay. So we have our command Here we go. So this is the command we want to run that will open up a shell on port 1234 on the victim. So I will grab that. I'll come over here. I will just insert that, and then I'll put in a space. And then I'm going to submit it and see if it goes through. So command submitted. And then once you submit that, then we will, from the attack box, we'll use net incat to then connect to that port only if it opens. If it didn't open, and you're not going to be able to connect because it was filtered out. So let's go ahead and see if we can run it. And it says connection refused. So that didn't work. So let me go back over here. All right, so it says you just need a space. Let me scroll up here. And again, I ran into issues when I first did this. So wonder if they want us to base 64 it. I doubt it. All right, let me play around with this, and then I'll show you how it worked. All right, so after actually reading through it like I should have the first time, we can see here that I just put in space, control F it. I look for the word space because I knew, okay, if I can find it, then I could figure out what command to run. And we can see net, or I'm sorry, in cat space dash. It will still run as if it was in cat space dash, right? So if we put two spaces there, it won't interfere with the command. So it's exactly what I did. Put two spaces here, ran the command, submitted the form. Then I tried to connect using the command they provided to try to connect, and it was successful, right? So I was able to then connect to it, and I can now see the user, which is the flag. Okay, so that was very easy. Why don't I just throw that in the notes as well? All right. We got that in the notes. Because that's almost as important as the flag, right? I mean, if you miss that, you're going to be in trouble. All right. So next task is task 6. Let's go on to task 6 here. Evasion via route manipulation. So we have route, source, routing, proxy servers. And just reading over this, essentially what you can do is you can have your traffic routed through another machine or through a SOCKS proxy. And SOCKS, the way that SOCKS works is it's similar to the way that you would route. Okay, so if you know what the Tor network is, you know how the Tor network works. If you don't know how the Tor network works, just hold on, just hear what I have to say. Okay, so you have nodes. Nodes are just systems. Your traffic goes from let me put this down real quick. So let's just pretend this is a node. Okay, so this is a node. So traffic goes through here. Okay, oh, my node disappeared. It goes through here, and then let's just pretend you had another node. So let's just say this was another node. So then it would, sorry, not disappearing. It would go from this node to this node, right? And then from that node, it would go on to another node, which is another system. So your traffic is just going through systems. So you can use SOCKS to have your traffic route through other systems. How this can be helpful is that because it's going through multiple systems, right, it's hard to trace it back to you. It's used for the Tor network. Also, it's good for evading or changing up the route and how your traffic is getting to where it's supposed to get to. So if you didn't listen to that, if you didn't hear me because I had my mic kind of far away, you just have one node and your traffic goes from this node through another node and then off to another node, depending on how many proxies you have established with socks. Okay. So here, protocol used in SOC servers can be HTTP, HTTPS, SOCKS 4, SOCKS 5. Which protocol are currently supported by Nmap? So with Nmap, you can use HTTP SOCKS 4. Okay, so that's the answer to that. Task 7, evasion via tactical DDoS or tactical DOS, denial of service, right? You just have to read over this. It looks like you're gonna DOS the IDS and IPS and logging server. I mean, if you have the resources to do that, sure. Um, yeah, that's an interesting way to do it. Task 8. C2 and IDS IPS invasion. So with C2, so your command and control, um, it can use different things like user agents. It can use sleep time. So it will, and just if you don't know what command and control is, well, you've done red teaming. Hopefully you know by now. Um, I think last time we messed with was Armtage, right, as C2. If you haven't, go watch that video. I'm actually in a stormtrooper costume for that one. It's pretty funny. I did it on Halloween, so I was like, might as well. Anyhow, so C2 is command and control. It allows you to have your victims connect, or maybe they'll just do a callback to the mothership, to the command and control, or receive commands from the command and control. The command and control can be configured so that whenever it receives these callbacks, these beacons is what they call them, then it can receive them at different times. It can be jittery in the way that it receives it. It can utilize SSL certs, so it can look like legitimate HTTPS traffic. You can use DNS beaconing because DNS um, is something that's used very commonly amongst computers to resolve names. So it wouldn't really trigger any alarms as long as you're not trying to like exfil DNS traffic. That might, because that would be a lot of traffic you're trying to exfil, right? Anyhow, so which variable would you modify to add a random sleep time between beacon check-ins? And that's jitter. Okay, so that's jitter. Next one, 9. Next generation security. So you have a lot of next generation firewalls. Essentially, what they are is they're just a firewall with a bunch of services packaged into one product. Okay, it's running your IDS, it's running your IPS, it's running your WFA, web application firewall. It's doing all types of different things. A lot of people like that. A lot of people don't. Some people are choosing to go with EDRs, um, you know, because response and detection, um, or endpoint detection response. So many acronyms these days. Just because next generation firewalls that are just the Swiss Army knife of firewalls, it can lead to a DOS in the case that it goes down, right? All your protection goes down. So you may, it's just not good to have all those services running on one product. I mean, a web application firewall, an IDS and IPS, having just that one product will decrease your bandwidth. Okay. Now imagine having one product that does all of that. Imagine how much that's going to decrease your bandwidth. It's going to decrease it by a bit. And that may not be a good thing. It may not be something your business wants. You definitely want to test it out before you implement it. All right. So, task 10. We are done. That's it. We have completed this. And I'm going to terminate this. Hope you enjoyed this video. Next video, we'll be covering the next topic. I'm going to leave a link to my LinkedIn. So if you just want to take a look at my LinkedIn, maybe you want to follow me, um, go right ahead. And my next video I'm gonna be doing is gonna be giving you some tips on how to get into cybersecurity because getting in is one of the hardest things to do. Once you're in, you're in. Once you're in, you're good. You put that stuff on your resume and you're going to get so many job offers. I'll tell you what, you get so many job offers and they will be lucrative job offers. But until then, it's kind of difficult, right? And I understand that. Believe me, I understand that. So I want to give you guys some tips on that for sure. Anyhow, hope you guys have a good one. Danny out.